Yeah, hey everyone. So for today's topic, I kind of wanted to cover memory management in Java. So oftentimes we'll see, especially in support cases, where there might be low memory conditions or memory is not properly sized for the JVM or for the usage of the JVM at certain points in time of the day. So before we cover all of that, we should first understand RAM, kind of what it does, what it is, and then we'll get more into Boomy's specific configurations. So with that said, what is RAM? So RAM, random access memory, is internal memory that's going to be used by the JVM. I mean, obviously it's used by the CPU, but just assume the JVM for now. So it's read-write memory. It's volatile. So by volatile, I mean nothing's really permanently stored in RAM. We'll talk about how memory is allocated from RAM in the next section, but don't worry now. But typically, if you want something permanently stored or more long-term, you would use something like a hard drive, like HDD, SSD, some sort of long-term storage solution. That is not RAM. Obviously, there's going to be faster performance when you're comparing them to something like an HDD or SSD. That's just how RAM works in general. There's nothing really specific about that. So with that said, performance can directly be correlated to RAM. So let's say you don't have enough RAM, you'll see negative consequences for that. One item that you might see is a low memory condition. So what happens under low memory within Boomi is the JVM is going to start flushing memory to disk. So let's say you have your main JVM, so you have your molecule node, and let's call that the parent JVM. Let's say it hits the low memory threshold. By default, that's 80%, but that's configurable if you want through an advanced property. I wouldn't worry about that for now because 80% should be fine. So what's going to happen here is the JVM is going to flush the memory to the disk, and disk is going to care more about completing the process over performance. So you'll see performance bottlenecks as that. Another item we see pretty frequently when memory is low is networking problems, believe it or not. So let's say the JVM is under a low memory condition. We've often seen problems where, let's say you're in a cluster, there might be multiple head nodes. Something can't write to its view file, whether it's the node itself or the other node. Items such as that can trigger a rolling restart and cause downtime in your environment. So you always want your JVM to have ample RAM. So we'll talk about how to monitor that in another section as well, but that's another suggestion. But with that said, your next question may be, how can I see what specifically, how much RAM is allocated, how much system memory I have, items as that. So if you go to your Atom Management Startup Properties, as you can see here, this is what I have. So maximum RAM available is the RAM available to the JVM. So in this point, my gateway testing atom only has that amount of RAM available to it. With that said, you can also see how much memory is on the actual system. So I have 16 gigabytes. Typically, I mean, just that this is on my laptop, so this isn't directly applicable, but there might be other applications running on that server, which we typically don't recommend. They can cause problems with port contention, eat up memory, items as that. In an ideal production environment, what we like to see is 80% of the total system memory available as RAM to the given environment. And we like to leave 20%, about 20 to 25% to the operating system. So the operating system can perform whatever tasks it needs to perform. So with that said, we'll talk more about monitoring the different items. So we'll talk about heap, stack size, memory management, how to unallocate memory from RAM, and items as that in later topics. All right, sounds good, guys. Enjoy the rest of your day.